A combustion reaction is a high-temperature chemical reaction between oxidants and a fuel. Typically, the oxidant is oxygen, O2, found freely in the air. As with any chemical reaction, if one of the reactants is depleted, the reaction stops. Here, this is demonstrated by placing a beaker over a candle flame. Quickly, the oxygen in the beaker is depleted and the flame gutters out. In this demo, we're going to be looking at the combustion of magnesium metal in a few different circumstances. Here you can see magnesium burning in air. This is an extremely exothermic and bright reaction, so bright in fact that it's not safe to look at it directly. The underlying chemistry is revealed in these balanced equations. Magnesium reacts with oxygen to form magnesium oxide, a very stable compound. Similarly, magnesium can also react with carbon dioxide to form magnesium oxide. In this case, carbon dioxide surprisingly acts as the oxidant and the source of oxygen atoms. This second reaction is an excellent example of the concept of lattice energy. In this slide, you can see each of the elementary steps used in calculating the overall lattice energy and net energy for this reaction. The reactants are separated into gaseous ions, and then they recombine to form the final products, magnesium oxide and carbon. Looking at the associated energy of each of the elementary steps, we see that the formation of magnesium oxide, which is very highly stable, is a lot of what drives the net energy of this reaction. To get started on this demo, I'm going to take these dry ice blocks out of a styrofoam container. And because we want them to have very flat faces, I'm going to put them face down on this metal cart. The ambient temperature from the room will actually cause this dry ice to sublime, slowly flattening it out the way that you might think of sculpting ice with a hot knife or something like that. So here's the block of dry ice. And by letting these sit here for 15 to 30 minutes, these surfaces that are actually quite rough will smooth out. Okay, a little while has passed. These are starting to get very flat on the side in contact with the cart. They've also got a lot of water condensed out of the air on top. I'm going to flip this one over and place an iron ball right in the middle. I'm going to use this to carve out essentially a little bowl to place some magnesium. And I'm going to let that sit for a while. Dry ice sublimes at negative 79 degrees Celsius, so the sound you hear here is gas escaping from underneath the iron ball. After 30 minutes, enough dry ice is sublimed to form a nice little bowl in the surface. The iron ball has cooled down to negative 79 degrees Celsius, and very pretty ice crystals have grown off of it, which is why I'm including this part in the video. This has carved out a pretty good bowl in this block of dry ice, so I'm going to remove the iron ball and I'm going to fill this bowl with magnesium turnings, which are basically just little chunks of magnesium. These are what those magnesium turnings look like up close, just little bits of metal. To get the combustion reaction started, I'm using a blowtorch to ignite the magnesium, and then I'll quickly cover it with a top slab of dry ice. With the reaction completed, all of the magnesium turnings have been converted into magnesium oxide, which is the white exterior of this shell that you can see here. The interior of the shell is made up of carbon, which was reduced from the carbon dioxide. Watching this reaction from a different angle, we get a better view of some of the combustion. One of my favorite parts of this demo happens here. The intensity of the combustion kind of sputters and flickers, similar to how the flame of a candle sputters as it runs out of oxygen. In this case, it's the magnesium that's depleted.